All right, here we go. This is problem number 70 from chapter 6 of the Halliday and Resnick textbook. All right, we've got this conical pendulum in which the bob, this little mass down here, is moving around in a horizontal circle at a constant speed. So we should already be thinking uniform circular motion. So the bob has a mass of 0.040 kilograms. The string has a length of 0.90 meters. And the circumference of the path is 0.94 meters. Okay, so we're trying to find the tension in the string. So before we go too far, so here's the deal. The tension is going to be directed this way along the length of the string, right? Now that tension is serving two purposes, right? So first of all, we're traveling in a circle, right? So there has to be some sort of force inward providing that centripetal force. And so what we're going to end up realizing, hopefully, is that our centripetal force is going to be provided by the x component of that tension. Okay? Now, the other purpose that the tension serves is it's pulling up in the vertical direction to counteract our force of gravity. Okay? So that's kind of the deal. Now, I'm looking at this length and the circumference and thinking that is going to give us some useful information, right? Because it means that I can find the radius of the circle, and that's going to then allow me to find this angle in here, right? We'll call that guy theta. All right, so let's see. So if circumference is 0.94 meters, circumference is 2 pi r. That means r is c over 2 pi. So if you plug this circumference in and divide it by 2 pi, you get a radius of, it's pretty close to 0.15 meters, but you guys know how I am with my significant digits. I always like to keep a couple extra. So there we go. That's what I used as my radius. Okay, and then obviously we'll round it down at the end. Okay. So what that means then is my rope, if you just look at the triangle formed by the rope, I know that my radius is 0.14 blah, blah, blah meters. It's just temporarily, just for notation. We'll round it up to 0.15 meters, right? And we know that the length is 0.90 meters. So I can find this angle by using an inverse tangent, right? Or no, inverse cosine, right? Because this guy's my adjacent, this guy's my hypotenuse. And so you get an angle of 80.43 degrees. Okay, so now the next thing, I guess, that we want to look at is the fact that, like I said a minute ago, we know that the y component of the tension has to equal the force of gravity, right? So that's helpful, right? So let me kind of clean up the board here. So I just cleaned up the board there. Okay, so I just said that we know that the vertical component of the tension has to cancel out the force of gravity. So my Fty is just going to equal mg, which is 0.04 times 9.8, so that's 0.392 newtons. And so the idea is I've got this tension vector that has an x component. Oops. Has an x component and a y component, right? And so the tension component vertically is 0.392. I know this angle here is 80.43 degrees. So now I can just use a little bit of trig, right? So let's see. The sine of 80.43 degrees has got to equal opposite, so 0.392 newtons over my tension force. And then algebraify this, and you find out the tension force turns out to be pretty close to 0.40 newtons. Okay? So that is that. And then for part B, to find the period of motion, we're just going to do this. Well, we need to find our centripetal force first, right? So the period is related to the velocity, right? V equals 2 pi r over t. So I can find my velocity, then I'm done. Shoot, I erased my radius. The radius was 0.15 meters, right? So the only equation we have would be this guy to get the velocity, right? And so remember, the centripetal force is just equal to your x component of your tension, right? So if you use a little bit of Pythagorean theorem or trig, you can find that the x component of this tension turns out to be 0.0660. It's got to be 81 that I wrote there. I can't read my own writing. Okay, this might be a 0, but I don't think so. Okay, okay, so that's our centripetal force, so now it's just algebra, right? So we're going to go to 0.066081 equals the mass, 0.040 times v squared over our radius, 0.15, and solve for the velocity. So if you do that, it's using some algebra, the velocity turns out to be 0.497 meters a second, and then plug it into this guy to find your period, and your period turns out to be pretty close to 1.9 seconds. All right, so there you go.